Hello.
Hello.
Hi. I am Sebastiano, and
Yeah, I'm Eugenio. Hi.
we're here today to talk about Flutter. Not about how to develop Flutter apps, because there's a lot of resources out there, especially a very good talk a year ago that you should probably also look at. But we're going to be talking about the Flutter internals and the framework.
A few disclaimers. So we have some code. We hope you can see it. Otherwise, we're going to give you the slides at the end. And those are going to include a bunch of links, including the talk we just mentioned, which is more of an introduction. So don't worry about taking notes or anything like that.
Yeah, there's going to be a lot of code which you can safely ignore for the most part. So we're going to start off with some trip to the past. Today, there's a lot of talking about Flutter. It seems like things are exploding. And in April 2018, which is this month, we are very close to the next Google I/O, which is in just a few weeks. And there's something like 10 sessions about Flutter at Google I/O, which we're very much looking forward to see. But it is not where everything started. Now, if you go back in time to pretty much something like a year ago, there was a talk at DroidCon Italy in Turin, which we did, which was, I think, one of the first few public talks about Flutter.
Yeah.
That was basically, I think, where things started picking up, not because we are just boasting about it, but also that. But in general, there's been a lot of pickup, and you could say that since a year-ish ago, things have been exploding. So it goes with a warning. We are boring. We talked about Flutter a year ago, and we're going to be talking about Flutter today. There is going to be quite a lot of deep dive into the details. If you feel lost, it's okay. We felt lost as well the first time. You're going to be able to catch up on the slides and play around with Flutter and actually understand what's going on. So, why are we talking about Flutter again? Well, first of all, because Flutter nowadays is going mainstream. As I mentioned, the public activity with regards to Flutter has exponentially grown. Not just from Google, which has spent a lot of effort with developer relations to promote Flutter and make it known, but also within the community. There's a Flutter Weekly newsletter, there's loads of tutorials on YouTube, there's a lot of activity that surrounds Flutter because people find it interesting. There is also Fuchsia, which is this open secret operating system that Google is working on that is open source, but they haven't really said anything about. But it feels like it's an up and coming thing, and it's really interesting because Flutter is the UI framework for that operating system. So maybe it will become something, maybe it won't, we don't really know yet, but it is still quite something that as professionals we should look forward to seeing and knowing about. And then in the meantime, we have become both Flutter GDs. Congratulations. It is just a label though. It just means that we have used Flutter at least once.
we tried the hot reloading, was awesome.
Yeah, exactly. We just stuck hot reloading for a few days in a row. That's how you.
It's like when you become developer in the about screen.
Yes.
You do it a few times and then.
Exactly. So Flutter has a very interesting value proposition, which is with Flutter you can create applications that look native and do have the behavior that you would expect on the platform that you're running it on, but you can also have it doing things completely differently. So for example, as you can see, you can have an application that has the material design language on iOS. Or you could have an iOS-looking application running on Android. So,
wait, did you just pesto because we're Italian?
Yes.
Okay.
So how does this happen? That was a very bad joke.
Thank you.
You're welcome. How does it work? Basically, when you have a Flutter application, what happens is that you ship an native application to the device. In this case, if you just run it on an iPhone, it will be an IPA, which is an iPhone app, which inside contains your application code, and it contains the Flutter framework, and then it contains the Flutter engine. Now, your application code and the Flutter framework will be written in Dart and will be theoretically portable without any changes, whereas the Flutter engine is the bit that is written at the low level, and you can think of it as the bare minimum amount of chromium that you can have to render stuff on screen, but not support web, because that's where Flutter was born.
It's almost like the drivers.
Yeah, kind of like. So that's the part you need to port to different platforms if you want Flutter to run on a different platform. Just the small bit. Luckily, they've done it for you. So what you can do is you can just take your application code, the Flutter framework, and a different build of the Flutter engine, and wrap it in an APK and run it on an Android device. And you will have an app that looks and works like a native app.
And actually, I wanted to say, oh, this is loud. I wanted to say that also they made really good work at making it embeddable anywhere. So right now the focus is purely mobile, but in theory, you could make it run anywhere native code can run. And in fact, there's like a desktop embedder already, right?
Yeah, experimental.
Experimental,
yeah.
But still, yeah.
So this is all very good, but the most important bit is if you write a Flutter application the right way, which is the easy way, your application will not just look native, but it will also feel native, which is very important because that's where most cross-platform frameworks fall short. You can either have something that doesn't look or doesn't feel native, or you can have something that does look and does feel native, but the cross-platform part is completely lost.
Or both.
Or both, yes. There's also that. Cordova.
I guess neither. Then.
Cordova.
Cordova.
Yes. So we are going to start looking at a simple example. So we have a card on Android. Everybody knows what a card is. It's just a material thing. It's in the material specs. It's a rectangle with rounded corners and an elevation that defines a shadow. That's a card. Easy, right?
How hard can it be?
Yeah. Cards can also have ripples. For example, if your card is clickable and you have the right, on Android, you would have the right foreground, use a selectable item background. Actually, it's surprising, but it's called background. And that is what it would look like on Android. You have click, you have long press. That's a normal card. Now, on Flutter, you're going to have the same thing. It will look exactly the same, minus the size, because I kind of screwed that up.
Well, to be fair, you were doing it 10 minutes before the intro, so.
Make it 5, yes. Yeah. So, as you can see, they look pretty much the same. There's some difference. There is one thing that you probably don't suspect at this point, which is that the first one was actually Flutter, whereas the second one is the Android one. Now, I do realize that you don't really see them on this projector, but I swear they're there. Pretty much, yeah. So that's actually the ripple on Android P on the Android side, because it's very different from the ripple in previous versions of Android, which is more similar to the one in Flutter, which is more material spec compliant. So how does that work on Android? First of all, you have to forget about KitKat. It doesn't exist. KitKat and lower, no way. You cannot have ripples on KitKat and lower. I'm just going to not repeat and lower every time. You can have rounded corners, and you cannot have elevation and shadows. They're just not supported. Actually, that's a lie. You can have ripples, and you can have rounded corners, but they're going to be inefficient as hell, so you don't want to have them. As for the elevation and shadows, there's no decent way to do it. There is some crazy hacks that you can do, like the card support library does, is basically using gradients and shapes to emulate shadows, but they don't work the same way that they do on Lollipop and later. But that is not really important, because in computer graphics there's a golden rule, which is fake it till you make it. Look convincing.
Also applies for public speaking.
Yes. Are you implying anything?
No. Not at all.
So for today, we're just going to look at MinSDK 21 which is Lollipop, which is what you should push for anyway. So the first layer that we're going to encounter on the Android side is views. Now, views, in this case, a card view, they have a background. The background is a drawable. And to be specific, it is a shaped drawable. Except, well, it is not really. It is a gradient drawable. The reason is, even though it doesn't have a gradient, it is because it has a stroke. So for some reason on Android, shapes that have strokes become gradients. Naming is hard. I don't know. Yes. But we're digressing.
Yeah.
Let's digress some more. So on Android, everything is compiled into so-called render nodes. So what you see from this point onwards on Android is all private APIs. There's no way you can touch them, except if you do crazy reflection tricks, which are not going to work on P anyway, so you don't want to do that. So what is a render node? Basically, a render node is what you could call an atomic unit of something that can be rendered. It doesn't mean it's a simple atomic unit. It's a complex atomic unit, which means it contains draw commands, but it also contains, for example, transforms and so on and so forth. Once you have your view will have several render nodes. It will have one for the background. It will have one for, depending on implementation of the view, for different things. Now, if you create a custom view, you cannot directly create a render node. Everything that you do on draw will end up in the same render node, which is the main render node for your view. But you cannot have layering of render nodes by yourself. Once all the render nodes are drawn, they get collected in the so-called display list. A display list...
Not drawn, like more like created.
Yeah, I'm going to get there. Yes. So once everything is collected inside a display list, then, well, you haven't still drawn anything yet, because what actually happens is that render nodes are kind of like log entries for what you're trying to do, and then you compile a log of all the operations that you're trying to do, which is the display list. Where does our shape drawable sit in all of this? Well, it actually sits inside of its own render node, which is one of those. So our card view has a bunch of render nodes. One of them is representing the background. Now, this is where we go one level deeper. And this level is the render thread. And yet, we have not drawn anything to screen. So on Android, there is the so-called deferred drawing model. So nothing you do on a canvas, when you say draw circle, that's a lie. It's not drawing anything. It's just saying, okay, at some point I'll draw a circle there. Again, it's sort of a log of operations that the system will go through at some point, somewhere. And now we're going to see where. So it's deferred, and as I mentioned, views do compile display lists. Once you have a compiled display list, all these things are sent by the framework to a different thread. So you move off of the main thread and onto the render thread. The render thread is a thread, as the name implies, that renders things. Surprise.
Wow.
Yeah, I know. And basically, you can think of it as this just giant machinery thing that you throw your display lists in, and it just gobbles them and spits out something else that goes all the way down to the native layer.
So, like, what we see on screen is nothing.
Thank you. So the native layer, you will find a canvas. Now, you will think, oh, canvas, isn't that something I know? Well, actually, no, it's a false friend. Because it is not the usual canvas. It's not.
Trust it.
Yes, it's lying to you. It is a hardware UI canvas. Now, hardware UI is the underlying rendering platform on Android since the Honeycomb days. Android originally was using Skia, which is a name you'll hear again today, to draw its UI on screen. Skia is a 2D rendering engine, which is the same that Chrome and Chrome OS use to draw things on screen.
Created by Google,
yes,
open source.
Also created by Google and also open source. Hardware UI was done because back in the day of Honeycomb, there was no good way to have hardware acceleration on Skia. And that is a problem when you're trying to draw to a big tablet screen. So what they did is, instead of waiting for the Skia team to finish their OpenGL-based backend, they created Hardware UI, which is a separate rendering engine, which is completely separated from Skia, even though it has a similar API at the interface level, because then it was easier to swap. Now, once you have the canvas is the component that will, the Hardware UI canvas is the component that will eventually actually, draw on the CPU, on the GPU. And then what you have is pixels being colored.
Yeah, nice. Oh, and you should say from Android P, Skia is now finally the default again.
Yes, so starting from Oreo, in the developer options, there's an option that you can choose the default render for it being Hardware UI, which is the default, or Skia Hardware Accelerated. In Android P, Skia Hardware Accelerated should be becoming the default one. But it's not completely replacing Hardware UI yet. I'm not sure if it ever will, but that's the state of things. So with this, we're done. We have drawn the background, just that thing. So what about the rest? Well, just to make it quick, because I don't want to go through the same circle over and over again. Let's say we want to draw the elevation shadow. Now, the elevation shadow, it lives in the main render node for the view. And a render node can also carry information about the outline and the elevation of the contents.
Oh, yeah, and so it's an extra property on the render node. It's like an exception because it's different. It's treated differently than everything else.
Yeah, it's treated in a specific way, and you have the outline and the elevation value, and based on that, then basically everything goes into, at the hardware UI level, it goes into a class that sounds like a transformer villain, which is shadow tessellator, which simulates the area shadow that the material specs actually define. And that's what draws the shadows. And that is also why you kind of have convex paths for the outlines, because it's cheating. And if you have a convex path, you will see very weird artifacts. And it's kind of weird.
Peek behind the curtain.
Yeah. And so on and so forth. That's how Android works. So we've seen Android. And now we're going to actually go back to the beginning, because now we're talking about Flutter.
All right. So Flutter is different. It's different because it draws things directly to the screen, which is the same that Android does, but it uses a completely different approach. So the first difference is that on all the platforms where Flutter is available, you can do whatever Flutter is capable of. There's no difference between the different Android versions or anything like that. So Flutter is available on API 16 and above on Android, and 64-bit on iOS. They are doing the 32-bit on iOS, and they're preparing the x86 on Android as well.
Yeah, Flutter currently doesn't work on very old iPhones or on Intel-powered devices on Android, if you still can find them around.
Yeah. So what do you get on all these platforms? You get three things mostly. You get ripples, real thing, everywhere. There's a widget called Inkwell. You get non-rectangular clipping, like efficient one, and you get shadows. Which is great, and we'll see how that actually happens behind the scenes. We didn't talk about the threading in Android, right, in the end? Well, we said render thread, yeah. So Flutter has different models, so we have 4 threads, pretty much. One is a platform thread, where the integration with the host system is executed. So that's, I think, like the Android, for example, main thread. That's a platform thread. Then you have a UI thread, which is where all the Dart code is executed. So that's the main thread for Flutter, pretty much. GPU thread is the, that's the equivalent of the main thread. GPU thread is the equivalent of the render thread. And then you have an IO thread, where you would do all the long operations. So I guess it's equivalent to an async task, more or less.
Please, no.
Just kidding. Yeah, so let's jump into the first level. So Flutter is very much layered, and the highest level is the material framework, which is something built on top of the standard tools. So we want to draw the same humble card as before. How do we do that? Can you see anything at all? Yeah, confused faces.
Well, there's not much you can do if you cannot see it.
We will do a dramatic reading of the source code now. No. So the point is, it's really, so this is not just like your main screen. This is the entire app, all of it. And yes, it does fit on one line.
Shut up.
Okay. But anyways,
This is not JavaScript.
It is true though, it's not JavaScript. Don't spread the rumors. On Android, you compose your UI by nesting views, pretty much.
And inheritance, mostly.
And a lot of inheritance, yes, correct. In Flutter, you use 3 techniques, mostly. You use composition, when you have your widgets containing other widgets. You can use Mixins, which are classes without a constructor. So in many ways, they allow you to have a sort of multi-inheritance without the drawbacks of it, which is also a very nice way to share code. Or you can use inheritance, of course, which sometimes is what you want. And one thing to note is that in Dart, so there's no interfaces, no real interfaces. Everything is a class. And in particular, though, every time you declare a class, you implicitly declare an interface. So any class can, let's say, implement the signature of another class, but not the implementation. And so that means that if there's a type that you do not control, unless it's private, you can always be that type as well. So that's really good. Like you have no limitations in that sense. So yeah, compositions, as we said, it's like you have this build function for your widgets, and you just return more widgets. This is an example that you cannot see.
Basically, you're building the layout tree that you would normally build on XML on Android, for example. You're building it in code, in Dart, and you're building the hierarchy as a tree of composed or nested, if you will, widgets, because everything is a widget.
Everything.
Yes.
Yes. So it's pretty easy, and it's what you would do probably most of the time. It's the easiest way to just build your Lego blocks of code. Mixins, yeah, as we said, so they are like an abstract class without a constructor. You can think of it as a partial class in many ways, or like an interface with default methods, but that can carry state. So if you're familiar with the pattern in Java 8 or Kotlin, imagine that, but you can actually keep something inside, which is nice. And they work, why are we showing this? I don't remember. Why are we showing this? Interesting. This is yeah, now I remember. So this is the same application that you could not see before. We just changed it slightly for the sake of the example, because we are actually going to see how this code creates whatever it needs to create to draw on screen. So in order to not make it too long, we're just going to swap the last part, the inside, which is the one that would create the ripple. And instead, we're going to create like this fake content that we're going to call...
A size box, in case you were wondering, is a box with a size.
Names, right.
Surprisingly.
Yeah. So I don't know if you can see here, but essentially we have a container widget that contains a size box widget, that contains a card widget that contains this card contents placeholder that we created. In the end, this is the hierarchy. Very simple, but it's not the final hierarchy. And in Flutter, by the way, you can inspect all the widgets hierarchy when the app is running and see exactly what widgets are created, what nests what, etc.
So basically, one thing that has to be said, the hierarchy that you define in Flutter is not the hierarchy that goes on screen, because the framework will inject things for you in various places to fill in all the gaps to make sure that things work the way you expect it to.
Yeah, right. Like, if you're not familiar with Flutter, it follows the React pattern where this is a sort of virtual DOM in a way, in the sense that you're describing your intention to draw the UI. You're not actually telling the system yet how to draw your UI. Which is very nice for composability, but also it allows you to declare your UI the first and only time as if you were drawing it for the first time, and then it's automatically kept in sync with your state, and we'll see how that happens. Container is, for example, a widget that doesn't do anything by itself. It just contains other widgets.
It's kind of like a frame layout-ish.
Pretty much, except, again, like, because these are widgets, they're not the things that actually draw on screen. They don't have the same cost. Widgets are immutable and very, very cheap to create. As a matter of fact, you can even have them constant somewhere and just reuse them in multiple places in the app.
Because it's code.
It's code. And they're just like, again, a configuration of something you want to put there, but not necessarily the actual thing. So the container just creates an align widget, because in this case, we wanted to center the card. And it also has a decorated box, which is something that draws the background in this case. And then the card, which is the interesting part, is where we want to start digging. If we jump into the declaration of the entire card widget, this is the code, minus comments.
Quite a difference from the card view on Android, if you have ever seen the source.
Yeah. This is it, and what it does is it just adds more widgets. It doesn't even do any drawing directly. And so, as we will see from here on, anything we see, we can change, actually. So all of this, you can just copy-paste in your own class and modify it however you want, which is not the case on Android. So in this case, we return a semantics widget, which is something that tells the accessibility system what it means. In this case, it just says something like,
I am a container.
Yes. Yeah, exactly. And then we have another container. In this case, like the framework, adds it to a margin. And then we have this material widget.
What is material?
That's the question, yes. So material, this is a way to encode the material metaphor that is much closer to the guidelines, to what the Google designers wanted originally, because it's an actual thing. Like, this is a piece of that material in the metaphor that can change shape, that can draw the ripples, that can be clipped, etc. And so what the card view does, widget does, is that it configures a material pretty much. That's what it does. And so we see that the material is the last element. And then the container adds a padding because we added a margin, and so that's it. And finally, we see that this is the material. Again, it's a stateful widget, which is a different kind of widget in the sense that it doesn't directly return new widgets. It has a state. And every time the state changes, it just returns a different subtree of immutable widgets. And so the way it works is that you say create state, and then you have your own class with the state. And just to show you that they are literally just accepting some parameters, not doing anything fancy, just doing that. And then from the state, they actually do more things. So in this case, they add like an animated default text style, which is something that you have a text style, you change it, and they automatically animate between the two, which is awesome.
It's kind of like the CSS transformations where you can have the default state and then you have a specific class for hover, for example, and then you say just transition using this curve, and this does the same thing.
Yeah. And you don't have to do anything on your side. So it does that, which also adds a default text style, which is a way for you to inject your style in like a subtree of widgets. Then they add more. There's like a notification listener, which is something used internally to know whenever the layout inside is changed, so that they can change the way the ripple, the shape of the ripple and the size of it. And then there is this ink features, which is the thing that draws the ink ripples. And we're going to see what's inside of that. Quick note, you see probably maybe an underscore at the beginning of the name. That's because in Dart, every time something starts with an underscore, it means it's private. There's no modifier you need to add, you just do that, and the compiler will make sure that things outside your file will not be able to touch it.
It is file private.
Yes, and it sounds gross, but it actually works. Like, I don't know, I'm starting to like it.
It's just a matter of habit.
Yeah, I guess. And then we do, and then after all of this, we have this material interior, which, where is it? I don't know. Somewhere.
Yeah, it's a separate class.
It's a separate class, yes. This is the last piece, and the material interior is literally the contents of the material part. Again, it's an implicitly animated widget, which is the same as the automatic style animator.
Yeah, sort of.
And it extends a stateful widget again, so inside you will have a state, blah, 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 etc. I won't show you everything because you get the gist by now, but essentially it adds more widgets. It adds a physical shape, which is, well, something that has
A physical shape.
a shape, yeah, and an elevation, and shape border paint, which is the thing that draws the rounding border on the card. And that's it. That is the final hierarchy. Oh, well, except one point. The shape border paint adds a custom paint. And that's really it, I promise. This is the whole hierarchy for that scene, if you want to call it. But what does it mean? Like, this tells us nothing, essentially, because the point is that not all these widgets are the same. Some of them just return more widgets, but actually every widget has the ability to create something that we're going to see in a second, and that something actually draws on screen. And so we see how this connects to a parallel hierarchy that is the one that is really interesting to see. Then
We are here at the end of the journey inside of the material world, in a way. We're about to move to a separate.
Yeah, actually, fun fact, of all of these, only a few are really material. Oh yeah, we removed the last one because it's not relevant. We created that for fun. So these ones are the ones actually in the material layer. Everything else is part of the normal widget layer. So there's really like a few classes that belong to the material one, although they do a lot of things, but everything else, like you don't have to use them, is what we're saying. So, widget layer, which is what material builds on. And so, starting again from this hierarchy, what happens? So as we said, every widget can, but not all widgets do, create an element. Elements are the glue between widgets and this other thing that really draws on screen. Because you recreate your widgets every time you change something, you need something to be there and decide if what you did was actually a change. And if it is a change, it will update the other thing that draws on screen that we're going to see. And so that's the element purpose, let's say.
It's differ, sort of.
It's sort of like an adapt.
Yeah.
I don't know. Or a view holder, perhaps.
Yeah,
is more,
view holder is
yeah.
probably.
Yeah, and we've actually seen them before, because it turns out that they are the build context. So every time you have this build function, you get this context object. That is an element.
Is not the Android context.
It's not the Android context, although in a way it serves in a similar way. But so what happens is that every time you create a new widget, the context will become the parent of the returned widget, and so on and so forth. And so, for example, a common mistake is that when you're trying to show a snack bar, I really hope you can see it. Well, at home you'll be able to see it. When you show a snack bar, you need to access the material scaffold, which is a wrapping widget that has like the app bar and all these utilities. It's very easy to just say, give me the scaffold relative to the context, but that context is not the context of the scaffold. In order to access the context of the scaffold, you need to have something inside the scaffold. And so the way you fix this is that you need to create either your own widget or have a builder, which is just a very simple widget that accepts a function to, again, create a widget. So this way you get a second context, which is inner to the scaffold. And now, if you ask for the scaffold, you actually get it for real. And then you can show your snack bar and so on and so forth. Now, elements, though, are just a glue. They're just like a middleware between your widgets and the rendering. And the actual rendering is done in a render object. So every element creates a render object. And render objects are actually the equivalent of Android views. Why? So they are mutable, which is very different from widgets. And pretty much every time you change a property of a render object, you're probably drawing something on screen. So you're invalidating something somewhere that will eventually result in a drawing operation. And render objects do a lot more than that. They do all the layout. They do, Can you remember? So all the clipping, they do all the paint effects, they do really a lot.
All the drawing.
All the drawing, essentially, yeah. And so let's see how they actually map to each other. So this is the base signature of the render object. And yeah, they also handle the input, all the touch inputs. And so what happens is that from here, you say something like create render object. When you do that, you return a different object, just like this render physical shape. Now we are back into the physical shape widget that was created before. And you see also how there's two functions. There's actually more, but one is to create the render object, and the other one is to update it. So every time the widget changes, you take the old widget, you take the new widget and say, okay, well, given that, I think we should update the screen with that.
They have a longer life cycle than the widgets
Definitely,
that are
yes.
represented by them.
Yeah. And keep in mind that you will very, very rarely write your own render object. I don't think I've ever written one, honestly, because all the most basic operations, which you can compose very well, have been written for you by the framework designers. And
they're all accessible.
Yeah, it's super accessible. You can jump into the code at any time and understand what they do, etc. So this is one example. And so what happens is that from this hierarchy, some of these widgets return.
Just one.
Yeah?
Just one click.
Just one click? Oh, okay.
Yes.
Ooh, how fancy you changed it.
Improvements.
Yeah. So we create a parallel hierarchy, which is the render object hierarchy. And now that we have this, we have the real set of layers that are going to be sent to the GPU thread, essentially, and then rendered. If you're curious about how this all goes down, especially about the shadow, because we saw that on Android, this is what happens. So this is inside render physical shape, which again is a render object. At some point you have a paint method. And inside that paint method, you just say, well, if you have an elevation, draw a shadow, which is very different from Android because that's not an exception at all. We're just saying this is a normal drawing operation. You can do it too in your own painting. And we're going to do it here because we need to, because we're drawing the shadow. But again, you can change all of it, and you can do it as well. Like, there's nothing special about it.
Yeah, this is still at the equivalent level to the on-draw.
Pretty much.
That is very important difference because you don't have to go all the way down to draw the shadow, which means you can change the shadow.
Exactly.
You can color it.
I mean, in Flutter, you can change even the engine if you want to, but that's rarely what you want.
Not even anyway. You would do that.
Yeah, probably not. I mean, I did compile my other. Okay. And then after this, we jump into the canvas, which is another layer. That's the Dart UI layer, which is really the canvas UI, pretty much. The canvas API, sorry. So you have everything you would assume you have if your app was just one big, giant canvas. So there's no layout. Yeah. It's really only about painting.
So we're going down closer and closer to the rendering engine. And now at this layer, there is no more widgets. There is no abstraction. This is just, I have a surface and I have pixels and I need to color the pixels. That's it. That's all it knows about.
Yeah, as efficiently as possible.
Yes.
And so actually, here you even have access to all the display list equivalent that it's on Android. They're called layers here. But you can really change how things compose at the GPU level. And you can, like, it's just part of the API. There's nothing special about it. There's nothing hidden. You can just use it if you need to. Of course, it's an advanced subject, but you can definitely use it in special optimization cases. So inside the canvas, just for fun, we're going to jump more and more into it. And so the draw shadow function, what it does is that it just calls to some native code, which is canvas draw shadow. And that goes into the next layer, which is the Flutter engine. And if you really want to see, I know you do, this is C++ code that does the draw shadow. And it calls into some other draw shadow in a different package, which is more about the shapes and the material stuff. It's like a specialized version. And when it does that, there's more C++ code. And then at some point, it just draws directly into Skia, the library we said before. And that's it. Like, that's literally all the code, pretty much. When you jump into Skia, we can finally see how Skia works. And, I guess we can look into Skia. Well, whatever, let's go on. At this point...
Hot reload the kernel.
Yeah.
That's it? Yes.
Did they buy it?
I don't know.
Oh, I don't know.
Did you buy it?
So we'll give you the link for the slides at the end. But if you have any questions in the meantime, we'll be happy to answer.
Thank you.
Okay.
Any questions? If you...
Yeah.
You can also find us around later, probably, or on Twitter.
Actually, I'll just go to the last slide, so you can, if you're curious, you can get the slides and follow us on Twitter.
We haven't put up the slide set because we are...
Oh, correct.
Yes, we need to do it now.
5 minutes
but
after this.
make it an hour. Just make it an hour.
Yeah. So hi.
So, hello guys, thanks for the talk. I was guessing, do you know how is UR rendering performing compared to constraint layout, for example, in pure Android?
Well, you mean if you change something or just statically appear?
Do you have any insights about performance of a pure Android developed applications with a constraint layout UI and this engine that you just present? There's no difference, maybe?
So Flutter has as a goal to be as performant as possible, and so they try to hit 60 frames per second all the time. Okay. And depending on how you manage things, you might be able to be more efficient than on Android. It's a different system, so like there's a few gotchas that you might need if you're doing complex drawing, but in general.
I think it's not really a parallel that holds too much because constraint layout is a very powerful layout that tries to flatten everything or make you be able to flatten everything because on Android views are expensive and so you want to minimize the amount of views and there is still a certain level of disconnect between the layouting and the drawing. Whereas on Flutter, you're not directly defining the view hierarchy. You don't have anything that is similar to constraint layout. So you can maybe compare the performance in drawing a single widget, like a text widget and a text view, but comparing the view group performance of constraint layout, there is no one-to-one equivalent on the Flutter side,
okay,
so it's kind of hard to answer this.
And I think like Flutter in general has much more predictable performance. So if your app is lagging, it will probably lag everywhere, and if it's not lagging, it will probably not lag anywhere. So and Android is more like hit or miss. Like it depends. Of course, you need to take into account how powerful the device is, for sure. Yes, but like if you have like specific hiccups, they're always going to happen more or less there, and not like surprising.
Mostly because you ship the same engine everywhere.
Yeah, exactly.
So.
Okay, thank you.
Thank you. Anyone else?
No? Cool. I think we're done.
Yes.
And
well,
with 2 minutes to spare.
wow, sweet.
One.
Thank you very much then.
Thank you.